Hello students, to continue with the nomenclature of the organic compound, this is my second video. In my first video I told you about the root name of the organic compound. The root name of the organic compound is very important to understand. I took the example of hydrocarbons. As you know, there are three hydrocarbons: alkane, alkene and alkynes. You will find a common group of letters in all hydrocarbons, that is alk. When you take alk as a common, so in alkane the alk plus ane, in alk plus ene and alk plus ine. So alk is the root name of all aliphatic organic compounds. Without knowing the value of without knowing the value of alk, you can't write the name of any compound. So first of all, you should know what is alk. It is very simple. You will find in your textbook that when there is one carbon atom in a compound, the name of alk will be meth, and C2 then the eth, and C3 prop, and C4 but. In the same manner, if there are 8 carbon atoms in a compound, then the name of the alk will be oct. So today I will tell you how will you get the value of the alk. How will you know the number of carbon atoms present in that chemical compound or the organic compound. So to know the value of alk, to know the exact name of alk, whether it is meth, eth or prop, so you should know about the selection of the longest chain. The first rule, IUPAC first rule, most important rule, that is the selection. The location of the substance group, to show the location of the substance group. To make you understand, I would take an example of the molecular formula C6H14. C6, the molecular formula C6H14. If I say to you that write the possible structures of this C6H14, then you will write C3, CS2, CS2 and CS2, CS3. All this structure has 6 carbon atoms and 14 hydrogen atoms. So it is, if now I will ask you what is the name of this structure, you will find that there are 6 carbon atom present in this structure. So the value of alk will be hex, and all the carbons are combined with the single bond. So you will suffix hex with ane. So the name of this compound will be hexane. Very simple. But in this second case, when I write the 5 carbon atom in a chain and the 6 carbon atom in the like a substituent group, so the name of this compound will not be hexane. How will you get the name of this compound? Again you will count the number of carbon atoms found in this chain. So 1, 2, 3, 4, 5. So here the value will be alk. The value of the alk will be 5, and the name of the alk who has the 5 carbon atom, the name pent. Pent will be suffixed with ane, because all the bonds are here single bond. All the carbon atoms are combined with the single bond. So it is the name of the carbon, it is pentane. So then in the same way, here again this third possible structure of the C6H14. So again these 5 carbon atoms are here, and CS3 I replaced here CS3. So again both this structure will be called the methyl derivative of pentane. These both structures. This both structure will be called as methyl derivative of pentane. So it is the derivative pentane. So now you should know, if I say to you, write this structure. If I want to make you write this structure and I say to you that write the name of methyl derivative pentane, so you will write, some students will write this structure and some students will write this structure. I want this structure. Who is at fault? I am at fault. I didn't give you the exact location of CS3. When it's so, I should tell you about the location of the CS3, whether it is on 2 carbon or 3rd carbon. So the second, you need to know about the second carbon, the rule of IUPAC, to show the location of the substituent group. So these 2 rules are very important. The first rule is the selection of the longest chain, and the second rule is this, to show the location of the substituent group. In this same manner, again I tell you here I take the chain in 4 carbon atoms, so it is butane. So here 2 CS3, here 2 C, both these CS3 group are present on 1 carbon. So here again I need to tell you the location of the substituent group. So this is to tell you about this both group, I will take an example. Before telling the selection of the longest chain, I want to tell you about the types of carbon atoms. There are 4 carbon atoms, types of carbon atoms. 1, primary carbon atom. Primary carbon atom. The sign of the primary carbon atom will be small p. If a carbon atom is combined only with 1 carbon atom, that will be known as primary carbon atom. In this, ethane, CS3, C2H6, C2H6, both the carbon are primary, because this carbon is combined with 1 carbon and this carbon is combined with 1 carbon. Both the carbon atoms are primary carbon atoms. So here, this is primary. Here in this chain, the carbon atom found on the end of the chain, both this one and this one are this 1, 2 and 3. 1 and 3 carbon atoms are the primary carbon atom, but the secondary carbon, this carbon is known as called secondary. The carbon atom which is combined with 2 carbon atoms. It is combined with 2 carbon atoms, so it is secondary carbon atom. It is secondary carbon atom. Secondary carbon atom, and the symbol of the secondary carbon atom is S. In the same way, here this is butane. This is structure of butane. So here you will find the 2 carbon on the end. Both are primary carbon atom. This is primary. But the middle carbon are combined with 2 carbon atoms. This carbon atom is combined with this and this carbon is with this. So it is secondary carbon atom. It is secondary carbon atom. So you should understand secondary carbon atom. Now I am telling about the tertiary carbon atom. Tertiary carbon atom, the sign of the tertiary carbon atom is T. When a carbon atom found in the carbon chain which is combined with 3 carbon atoms. This carbon is combined with 1, 2 and 3. Or you can say this carbon is bonded with 3 carbon atoms. 1, 2, 3. So it is tertiary carbon atom. And rest of all 3 carbon atoms are primary carbon. These are the primary carbon, because this carbon is attached only 1. This carbon is attached only 1 carbon. These are the primary carbon atom. So there are primary, secondary and tertiary. Next, if a carbon atom is bonded with 4 carbon atom, then the carbon will be known as quaternary carbon atom. This is quaternary carbon atom which is bonded with 4 carbon atoms. So there are 4 types of carbon atom. This will tell you about the secondary alcohol, primary alcohol. When OH is bonded with the primary carbon atom, then the alcohol will be primary alcohol. When OH is bonded with the secondary carbon, then the secondary alcohol. And if the OH is bonded with tertiary carbon atom, then the alcohol will be called as tertiary. So I will tell you more about the alkyl groups before going the selection of the longest chain. As I told you about the types of the carbon atom, now you should know about the types of the alkyl groups. So first question arises that what is alkyl groups? So when one hydrogen is replaced from the alkane, the rest part of the alkane will be called as alkyl group. As you know, the general formula of the alkane is CnH2n plus 2. One hydrogen will be replaced, then the rest part of the alkane CnH2n plus 1 hydrogen. This is the general formula of alkyl groups. So here when you write the methane, the group of the alkyl group of the methane will be methyl. This is CS3, 1 hydrogen is replaced by any other atom or group. So rest part, the CS3, methyl. It is CS3, CS2, ethyl group. Again CS3, CS2, CS2. It is N-propyl. It is known as N-propyl because this is chain 3 carbon atoms chain. If it is CS3, the hydrogen is replaced. So CH has one open bond to combine with other atom. So this alkyl group will be known as N. This will be N-propyl and this will. Both are the structure are same. This is isopropyl. If this is CS3, CH, CS3, this is isopropyl. The structure can be made like in this way. CS3, CS3 and CS3 and CH. This is as both the structure are same of the isopropyl group. So here, so know about what is isopropyl. When OH is bonded here with this carbon, so that alcohol will be called as isopropyl alcohol. If OH I place here OH, then the name of that alcohol will be isopropyl alcohol. You will say the name of that isopropyl amine. If here you N-propyl amine, propyl alcohol, N-propyl amine. So next come to the C4H10. This is butane, the alkyl group of the butane. There are 3 types of the alkyl group of butane. 4 types. CS3, CS2, CS2 and CS3. One hydrogen is replaced. So this remaining part of the butane will known as N-butyl. It is N-butyl. Again, if we replace the hydrogen, if we replace suppose the butane is changed into a branch, this is the CF2-methyl propane, so it is known as isobutyl. CS3, one CS3 is placed here, so this group is known as isobutyl. Isobutyl. Both the carbon atoms are primary carbon atoms, so n-butyl and isobutyl. Third one, this isobutyl can be written as in this way. Both the CS3 group are right in this way, and CS3, CH and CS2. This is also butyl, isobutyl. Now the first is n-butyl and second isobutyl. The third one alkyl group will be of the butane will be this one. The name of this compound will be secondary butyl. This is because the hydrogen is replaced from the secondary carbon. This is secondary carbon. So I told you about the primary, secondary and tertiary carbon. So hydrogen is from where the hydrogen is replaced? Hydrogen is replaced from the secondary carbon. So it is the secondary butyl. And this one CS3, CS2, CS3, this here also secondary butyl. This structure may be written as both the CS3, CS2, CS3, CS2, and this CS3 I write here CS3 again CS. You can strengthen it in a single in a continuous form like this. So it is also S-butyl. So here the fourth type of the butane alkyl group of butane, that is called as tertiary butyl. Tertiary butyl. When the structure are like this, in this way, sorry, here CS3, this is one carbon and this carbon is bonded with 3 carbon atoms. This carbon is bonded with 3 carbon atoms. So it is tertiary carbon. All the 4 carbons are here, so it is tertiary butyl. This can be written in this form and this can be written in this form. So these are the alkyl groups. So you should know, you should remember them always, that when I will call you about the structure of the isopropyl pentane, then you will write the isopropyl pentane. I can say. So the alkyl groups are very important to know, to write the structure of different organic compounds. Now I am going to tell you about how will you select the longest chain in an organic compound, the main IUPAC rule. So how to select the longest chain? I have written here 4 or 5 examples. Suppose this is the first structure. In this structure you should count. First I tell you that you are free to select any end of the structure. You can count the whole number of carbon atoms from this end, this end, this end, this end. One thing. It is not able for you count this from the left hand side or right hand side. You can count the number of carbon, start counting from the upper side, lower side, right hand side, left hand side. So count here 1, 2, 3, 4. 4 carbon atoms. Here 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So this chain, this here, this will be the longest chain in this compound. So here there are 6 carbon atoms. So it will be the derivative. The parent compound will be hexane. The parent compound will be hexane. The substituent group will be, I will tell further about the substituent group, how to locate the substituent groups. So here again, in the second structure, this is second structure. If you count 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5, 6. and 1, 2, 3, 4, 5, 6, 7. So here this will be the longest chain in this structure. So there are 7 carbon atoms in the longest structure. So the name of this parent compound will be heptane, the name, because all the carbons are bonded with the single bond. So the name of this compound will be, the parent compound will be heptane, 3 and 4 heptane. So again I am come to the third structure. This is 1, 2, 3, 4 and 1, 2, 3 and 4. If you select this structure, this is the structure, the longest chain you will find here, butane. Here you write the name. It is the parent compound butane. Now think what I am saying. If you write this structure butane, then it is wrong. Then it is wrong because I have written here C2H5. It is the condensed form of the ethyl group. So you should write this C2H5 in this way, CS2, CS3. If you write this in this way, CS2, CS3, then the number 1, 2, 3, 4, 5. The longest chain will be 5 of the 5 carbon atoms. So the name of this parent compound third, it will be pentane. It will be pentane. Pentane. The name of this compound will, because C2H5 2 carbon. You should write in this way in the open CS2. So don't write in the condensed form. If you write in the condensed form, then you will going to make a mistake in that compound, to name that compound. Again, this is the third, and I am coming this fourth. This is CS3, CS2, CS2, CS2. How can this? If you count this only, this is the longest chain. You are wrong. You are on mistake. So here, this both the end, you can strengthen this both end like this. If the CS2 here, CS2 here. So counting will be started from here. 1, 2, 3, 4, 5, 6, 7 and 8. It is octane. It is octane. Octane. It is octane. So count the whole. This is the way. How will you select the longest chain? Again here come, suppose this is the structure of this compound. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7. Here 7. Again count 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be the longest chain. In any way, in any end you can start from any end you can start the counting. So it is the 3, 4, 5, 6, 7, 8, 9. No-name. It will be no-name. So I told you about how will you select the longest chain. So longest chain is the first thing you should learn about the IUP system. This will give us the parent name or the root name of the compound. If you do any mistake in this selection, then if the root name will be wrong, then the whole name of the compound will be wrong. So you will be mistaken in that to write the name of that compound. So again I am telling you this, taking the structure. One thing more you should keep in mind. If you have such structures that I am writing the second structure, some structure here. Suppose here, this is the structure. One thing, CS3, CS2, CH, CS2, CS2 and CS3. Here CH and CH3. This is structure. CH3, CH, and here again I cite CH and CH3. Suppose this is structure. CH3, CH2, CH, CH2, CH3, CH, CH3. Again I am writing this structure here. CH3, CH2, CH, CH2, CH3, CH, and CH3. Here I write this structure. Again I am writing this structure here. So these both structure have you seen. So now try to understand what I am going to tell you. Select the longest chain. If you go 1, 2, 3, 4 and 5. This is the 1 to 5. This is 1 to 5. And again 1, 2, 3, 4 and 5. Again 5. And 1, 2, 3. So what will be the name of this compound? 1, 2, 3, 4 and 5. This is structure. And here in this way 1, 2, 3 and 1, 2, 3, 4 and 5. There are two chains. You found here two chains having the same number of carbon atoms. Here you also here take it this example 1, 2, 3, 4 and 5. 1, 2, 3 and 4 and 5. There are in both this structure you will find two chains having the same number of carbon atoms. So now question arises that which carbon chain you are going to select. Which carbon? So here again I am telling you a most important rule. The chain that have the maximum number of the substituent group will be selected. Again I am telling you the chain having the maximum group of substituent group will be selected here in this case. Suppose you select this case here. This is the 5 carbon chain. It has only one substituent group. One substituent group. And both these structure are same structure. Both this structure and this structure is both. Here you will count 1, 2, 3, 4, 5 carbon. So the longest chain you find the longest chain of 5 carbon atoms. In the same structure, again you can find the CH3, CH2, CH, CH, CH3. This is also 5. This chain has 5 carbon atoms. This chain has 5 carbon atoms. Both structures are same. Both these structures are same. But to make you understand, I write both these structures in two ways. With the selection of the how will you select the longest chain? So here you find that there are two similar chains having the same number of carbon atom. So question arises that which carbon atom, which chain will be selected, because both the chain have the same number of carbon atoms. So now I am telling you the rule, most important rule, always the chain that has the maximum number of substituent group will be selected. Again I am telling you, note it, that the chain that has the maximum group of the substituent group will be selected. So here this chain has only one substituent group and this chain has two substituent groups. The chain, which chain will be selected? That has the maximum number of substituent groups. So this chain has 2 substituent groups and this chain has 1 substituent group. So this chain will be selected. This should be known. Now I will tell you about the location of the substituent group. How will you show? To show the location of the substituent group, I have taken 4 examples. In these examples, I will tell you how will you show the location of the substituent group. So here, this is the CS3 group. You have selected the longest chain of the compound. The longest chain have 5 carbon atoms, so the parent name of the compound will be pentane, root name of the pentane. Now you have to show the location of the CS3 group, methyl group. So you should start numbering from on this chain. You will give the number. You can give number in this way: 1, 2, 3, 4, and 5. You are free to give the number from either of the ends: 1, 2, 3, 4, and 5. In this way, this CS3 group located on the 2 carbon, 2nd carbon, and if you start numbering from here, then this CS3 group is located on the 4th carbon. This is 4th. This numbering shows us it is 4th carbon. This numbering shows it is 2nd carbon. So one thing you should know: the substituent, the location of the substituent group must be at the least number. At the least number. So here it will be 2-methyl. 2-methyl pentane. The name of this compound will be 2-methyl. This numbering will be correct. This 2-methyl pentane. Again, I am coming to the second example. Here you can start the numbering from here: 1, 2, 3, 4, 5, and 6. This is the longest chain. 1, 2, 3, 4, 5, and 6. This can also be longest chain. But here you find the maximum group CS3 and C2. So this chain will be selected as the longest chain. Now you have to start giving the numbering. So here it is the number you have given this, and from this end you will find that this will be given to 3 number, and this will be given at 5 number. So this numbering will be right, and the name of this compound is right here CS3. The name of this compound will be 2-methyl, and here 4-ethyl, 4-ethyl hexane, 4-ethyl hexane. This will be the name of 2-methyl. Again, this is wrong name. So here, when you write these prefixes, they should be in the alphabetically order. So the name, it is the wrong name. So you should write 4-ethyl, because E comes first in the alphabetical order. So it is 4-ethyl. 4-ethyl. 4-ethyl 2-methyl. Methyl hexane. 2-methyl hexane. So you should be careful to write the name in alphabet order. So when the prefixes are written here, so you should write the name of these prefixes in the alphabetical order. So you should write 4-ethyl 2-methyl, not 2-methyl or 3-ethyl. It is wrong. It will be wrong. So you write the 2-ethyl and 2-methyl. Otherwise, half students will write 4-ethyl and half the rest students will 2-methyl. These both are the correct, but the name of the compound should be specific. So here the rules come that the prefixes are written in the alphabetical order. Again, I am coming to the third example. This is my third example. This is the longest chain 3 and 3 6 carbon. 1, 2, 3, 4 and 5 and 6. So here, when you give the number in this way, 1, 2, 3 from the left hand side, so the name of the compound will be 4-ethyl, 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 as you know that the E comes first in alphabetical order, so you write ethyl first, then 3-methyl, then it is 3-methyl, 3-methyl, and the name of the compound will be hexane. So the name of the compound will be hexane. So the name 4-ethyl 3-methyl hexane. But again, if you start the numbering from this end, 1, 2 and 3, 4, 5, 6. So the name of this compound will be 3-ethyl, 3-ethyl and 4-methyl and 4-methyl, methyl hexane, 4-methyl hexane. So the total number of the location of the substituent group is 4 plus 3, 7. 3 plus 4 is 7. Both are equal. So here question arises whether this name right or this one. This is for the 4-ethyl, 3-methyl and 3-ethyl and 4-methyl. Then here is again one ruling comes to I will going to tell you this third rule about this. The ethyl group will be preferred to avoid the list number, because ethyl comes first in the alphabetical order. Ethyl, so the list number will be 3. So this numbering will be wrong and this numbering will be right. So it will, the name of this compound will be 3-ethyl 4-methyl, because we prefer to award the list number to ethyl group, because ethyl groups comes first in the alphabetical order. So this name will be wrong and this name will be right. So 3-ethyl 4-methyl. So I am telling you about the list number. Award the substituent group must be awarded the list number, one thing. Then again I am telling you write all the prefixes in the alphabetically order. Third one, if two groups are of the same position, so you should consider the alphabetical order, the prefix that the substituent group which comes first in alphabetical order, that will be awarded the list number. In this case, ethyl comes first in alphabetical order, so ethyl is given the list number 3, not 4. This is it. So the name of this compound will be 3-ethyl 4-methyl hexane. And here in this case CS3. So right here you will write, start the numbering from here 1, 2, 3, 4 and 5. You will write the name of this compound 2-methyl. Again 2-methyl. And 4-methyl. 4-methyl and pentane. 4-methyl pentane. 4-methyl pentane. So this is again true. When same groups are present on a chain, the name of the substituent group are the same. So you can write this in this way 2, 2, 4 trimethyl hexane, trimethyl pentane. All these substances which are have the same name should be written in di, tri and tri. So here this trimethyl. No, you will not write in the separate way 2-methyl. No, it's wrong way. So this is the I told you about the how will you locate the substituent group. Now I am giving the most important tool. I am taking the example of decay. So this is the last example to make you understand about the selection of the longest chain, as well as to show the location of the substituent group. This is very technical example. Here I have taken the example of decaying. Suppose you start this number in this way. Here, if this is CS3 group is nearest to the end, if you start this number 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, because you think that this CS3 have the least number, because it is nearest to the CS3, so the CS3 is awarded to 2. Then the name of this compound will be 2, 7 and 8. 7 and 8. Trimethyl decane. Because there are 10 carbon atoms in the trimethyl, 2, 7, 8 trimethyl. If you start the numbering from this end, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Though the name of this compound will be 3 and 4 and 9. Trimethyl decane. The name of this 3, 4, 9 trimethyl decane, and here is 2, 7, 8. Which name is correct? Which name is correct? Here, how will you find the correct name? So here I am telling you that when you are in confusion to award the list number to the substituent group, then you should add all the numbering. So here the total of the 2, 7, 8 is 8, 7, 15 plus 17, 2, 8, 7, 2 plus 8 plus 7, 2, 7, 8 is equal to 8, 15 plus 17, and 3, 4, 9, 3, 4 plus 9, 3 to 7, and here it is the total number of 16. So this one, the total, the sum of the three number is 16, the sum of this three number is 17. So this will be the list number, so this name will be the right here, and again this name will be wrong. So here again, when you are in confusion that have I given the list number or to the substituent group or not, so please add the number of these substituent groups in like this, and consider and decide which total or which sum is the list. So the list total should be awarded to locate the substituent group. So this name will be right here 3, 4, 9 trimethyl. So So today I have told you about the rules of the IUPAC system. How will you write the name? So these rules are very important. If you try it, if you try to understand these rules very, then there will be no problem to learn about the whole IUPAC system, whole organic compounds, whether the alkene, whether they are alkyne, or the derivatives of the alkane and alkene. I hope that you will like this my video, and you will tell to your other friends and to learn about the IUPAC system. Thank you very much.